Happy Medical Physics Day to all the incredible medical physicists, not just today, but every day. I'm John Damilakis in my capacity as president of IOMP. So hello everyone from Vancouver, Canada. I'm here as ICMP member for the ICRP Committee 3 meetings and symposium. It's 4 o'clock in the morning. It's very early here. So across the world, a number of programs and events are organized today to inform people about medical physics and the role of medical physics in healthcare. IOMP is organizing this webinar, and the schedule is very tight today. So without further ado, I will pass the mic to Ibrahim. Dr. Ibrahim Duhaini is the IDMP coordinator, the coordinator of the IDMP events. So Ibrahim, the stage is yours.
Yes, good morning to you and good morning to the colleagues in the western side of the world, and good afternoon to the colleagues in the eastern side of the world. And happy Medical Physics Day. And we all know that the theme of this year is about medical physics for sustainable healthcare. This is the outline for the program. We have a small message, then we have the presentation by John, and then we have wonderful invited speakers around the world to enlighten us with their experience in the region. And then we will have a final session about discussion and questions. We hope to be very fruitful to all. For my message, I just want to convey the message that high quality healthcare services requires at least 3 important pillars. And these important pillars are advanced technology, the qualified personnel, and I hope that we are all going to be very qualified personnel in this field. And a third, intellectual systems. And these 3 pillars are all joined in the 8, in our poster for this year. We have 8 characteristics or duties and responsibilities for medical physicists to adhere to. This will give us a very sustainable healthcare services to convey good health and well-being for our patients. For no further ado, I will also would like to call in John Damilakis, our president, to convey his message to us. I will stop sharing and it's all yours, John.
Thank you, Ibrahim. So I hope you can see my screen.
Yes.
Okay, fine. So changes in healthcare are happening very quickly. It's difficult to predict where medicine and of course where medical physics will go over the next 5 to 10 years. However, the decisions and actions we take now will be critical for the future of our profession. The IOMP is leading discussions and listening to our members to understand their needs. How will the future of medical physics take shape? How will the role of medical physics and the medical physicist evolve within the healthcare team? And how can IOMP empower our profession to transform patient care? This is the subject of my brief talk today. Advancing medical physics clinical practice is one of our main goals. Medical physicists must be fully integrated into national healthcare systems as valued and fully recognized healthcare providers. How can we achieve that? Certification is inextricably linked with recognition. The IOMP is the principal supporting organization of the IMPCB, the International Medical Physics Certification Board, and IMPCB supports certification in accordance with the requirements of IOMP guidelines. IOMP's role in developing guidelines best practices, and professional policies to elevate medical physics practice in all patient care settings is very important. But it is equally important to educate the public, healthcare administrators, and policymakers about the essential roles and value of medical physicists. The IOMP has established the IDMP, the International Day of Medical Physics, and other initiatives to support these efforts, and will continue to raise awareness about the role of medical physicists play in healthcare. Medical physics workforce must be educated, trained, and prepared to serve in evolving healthcare environments as patient care providers. We also need to expand into other areas where clinical care can be enhanced with new physics contributions. The IOMP continues to fully support and encourage continuing professional development of the medical physics workforce by organizing webinars, by organizing the international conference, the World Congress, and by sponsoring and endorsing national events. Advancing patient care through innovation. So research means new knowledge, and without new knowledge, there is no future. We are working as medical physicists because of key developments in medical physics and research achievements such as the development of CT, MRI, or IMRT. We need to accelerate the development and adoption of innovations in medical physics. AI and other new digital technologies have the potential to transform healthcare. Medical physicists need to be sufficiently proficient in AI and new technologies. Scientific and professional societies have a great role in identifying the most important areas of research and disseminating relevant information. We are currently working towards that direction to identify those areas and organize workshops and other events. Shortage of medical physicists is an issue in many countries, in many parts of the world. Evidence-based developments in several pathways, such as the cancer pathways, the radiation protection pathways, or the quality assurance pathways, are often not put into practice because the medical physics workforce needed to support improvements is not available. An IOMP study on medical physics workforce is ongoing. We have invited our NMOs, our national member organizations, to participate in a survey that aims to collect information about the current members of medical physicists in their country, as well as about medical physics training and accreditation pathways currently implemented. It is our responsibility to highlight the fact that medical physics staffing crisis is expensive. It is also IOMP's strong ongoing commitment to promote and support efforts to increase medical physics workforce, diversity, and inclusion. So happy IDMP 2022, everyone. Thank you. I will stop sharing, and according to our program, I have the pleasure to introduce Dr. Paddy Kiligan. Paddy is EFOMP's president. Hi, Paddy.
Hi, John, and everybody. Happy International Day of Medical Physics. It's a great honor to be here across all these time zones to nearly, I think we've 1,000 participants. So yeah, it's wonderful. And it's a great theme, medical physics and sustainable healthcare. And actually a global approach like IOMP is really the only way to do this. So I'm going to share my screen now, and hopefully you will be able to see it. Can you see that?
Yes.
Okay. So when I was asked to do this, I was trying to come up with a definition for sustainability, and the most useful one that I found was on an Irish hospital website defined by the World Wildlife Fund, and it's an activity that meets the needs of present generation without compromising the ability of future generations to meet their needs. And a sustainable healthcare system is based on delivering high quality care and improved public health and well-being without exhausting natural resources or causing adverse ecological damage. So I hope, you know, in 21, 22, that the next generation or a few generations of physicists will be able to look back and think about how well we have done to deliver that. And by the first thing to realize is that we're all part of an ecosystem, whether a medical physicist working in the university or hospital or healthcare system, we're all part of society and part of the global planet. We need to be cognizant that we all have to play our role in ensuring that all parts of these ecosystems survive and that all diversity and everything else is taken into account. The EFOMP motto is that we like to apply medical physics to benefit patients and staff. And as John said, we need to make sure that the services we provide are relevant to the patients and demographic now and in the near future and in the long-term future that we serve. So we know that Europe's population is aging, so we have to look at how we will deal with that in the future. We need to make accessible and affordable high quality treatments and diagnostic using our medical physics, which minimize the negative impact on future generations. And as John said, availability of a highly trained medical physics staff now and in the future is key, that we provide a pipeline to ensure this expertise is there to serve these patient populations. And you know, these last few years have shown about the shocks that we've been placed on, and some people have been experiencing these shocks prior to us experiencing them, and we can all learn from each other, whether they be climate, the negative aspects of war, cyber attacks, physical attacks, destruction of infrastructure, poor electrical, heating and other supplies, and financial shocks to the system. So we're in a topsy-turvy world, and our services need to be able to sustain themselves through that. And we can learn from others who have already experienced some of these shocks. So for instance, in Ireland, we had a serious cyber attack, and in other parts of the world, you know, people would experience all of these things. So we need to learn together, and we need to do this in a way that has minimum harm to the environment and public health. We need to look at our radioactive waste. What do we use in production of the medical physics tools that we provide, and some of the equipment that John alluded to? You know, can we look at lengthening useful life cycle of equipment and how we would dispose of that? EFOMP's approach to a sustainable medical physics community in a sustainable healthcare system. We're a volunteer-based federation, so that we maybe don't undergo some of the shocks that other organizations may go through. In order to make sure we're relevant, we interact with a clinical organization and clinical professional societies and participate in international events such as this. We believe in the spreading of knowledge to Europe and beyond, and really encouraging development of regional medical physics organizations. We provide both online and hybrid resources through our educational platform, our congresses and schools. We do still believe that there is a role of face-to-face, but I think that there's a combined role with hybrid and online. Our congress is biennial rather than annual, and that leads to reduced carbon footprint. We try and maintain low registration fees so that we can make sure that it's sustainable for people to attend, particularly in low-income countries. We ran a session on sustainability at this year's Congress, where we had Rob Shooter from the UK talking about the carbon footprint of physicists and how they might reduce it, particularly through travel, actually. And we had Holger Wirtz talking about the solar-powered LILAC and you know, new ways of providing good environmental conditions for medical physics equipment. Adaptation and innovation are key, and we had a DIY fair to encourage a sense of innovation and to show that as physicists we can adapt quickly, including to sustainability issues. To feed the pipeline that the profession needs, we had a young person early careers group. We really do our best to encourage gender diversity and diversity in our profession, and I think that's a key to sustainability. Through our European partners, we like to inform strategic research, you know, groups through our working groups, through our EU projects with Euromed and common research platforms. And we've been dealing with issues around supply of radiopharmaceuticals, which are also key to the medical physics activities. We recently had a working group on the life cycle of the equipment and a policy statement So now we really need to include sustainability as something that we should think about at all stages in this life cycle. And I think it's very important. So whether you're tendering from disposal, that we maintain sustainability and reduce the future risk to future generations. So sustainability is something we, as medical physicists, need to think about, and we also need to act upon. So as Greta Thunberg says, so we don't want to just become blah, blah, blah. On a personal, scientific and societal level, we need to make our service relevant to our demographic, affordable and accessible with minimal harm. I think it should be easy for us, as we're generally well motivated for good, scientifically trained and innovative. A key to sustainability is addressing the inequalities and learning from the innovations in health systems that have already experienced some of the shocks that we're about to go through. I don't think anybody can say that they're immune to any of these shocks anymore. So I would encourage to involve yourself in NMOs and international organizations to advocate for sustainable healthcare. And you're going to hear a lot about that today, and I think it's going to be a very useful webinar. Maybe it's something we need to think about as part of our training curriculums, that sustainability, and we continue need to innovate and adapt. And I'm wondering, it's Marie Curie's birthday, happy Marie Curie, how would have things been different 100 years on, and how will things be different in 100 years time? So I think Marie Curie would have been an innovative adapter who came up with new ways of doing things and would probably have had some sustainable solution. So happy Medical Physics Day. Enjoy whatever's going on in your region. Yeah, we'll celebrate your wonderful contribution to patient and staff welfare. Thank you.
Good job, Paddy. Thank you for the informative from the EFOMP perspective. I now turn into the Asian perspective, the AFOMP, and I have a recording from Arun. He's currently on a travel. He's doing another conference in India. So I will share his point of views.
Just by the time I can wish you all very happy IDMP day, but I will not be able to share, so you have to play my recording.
Yeah.
Wish you very happy IDMP day.
Okay, I will try to do that. And let's see. We escape that. Stop sharing. Can you see that now?
Yes, we can see the PowerPoint.
Good morning, good afternoon, good evening, as the place you are in. Accept my greeting on the occasion of IDMP 2022. Thanks to IOMP for giving me the opportunity to speak with you. And I'm speaking today on the future of medical physics in a sustainable healthcare system where AFOMP stands. And as I talk about this year IDMP theme is medical physics for sustainable healthcare. And being medical physicist as a health professional, it's a very, very important to have a good professional education. And Albert Einstein has rightly said, education is not the learning of the facts, but also training of the minds to think. And therefore, we have to ignite the mind of the medical physicist to think professionally successful. As there's a huge development, technological development in the field of radiotherapy, radiodiagnosis, nuclear medicine, and all fields of the healthcare. And therefore, we need more and more clinically qualified, competent medical physicists, and who can work independently in various areas of the medical physicist. The GTFRC has, in one of its publications, recommended and shown that the medical education program should get enhanced, because by 2035 we will need more than 22,000 medical physicists for radiotherapy alone in LMIC. Countries leave aside for diagnosis and therapy. And therefore, almost 390 medical physics education programs, mostly postgraduate, have been started across the world. And in AFOMP region, we have 119 medical physics education programs, but the population is so huge, demand is so huge, it comes to be only 0.03 programs per million population compared to other USA and EFOMP region. It is much less, and therefore we have to increase this medical physics education program. Little bit of the AFOMP was started in 2000, almost 22 years ago, and we have today 21 member countries are members of the AFOMP, various diverse culture, education, and healthcare, and almost about 11,000 medical physicists are working into the AFOMP region to enhance the quality of the education and training and research. We have signed an MOU with the MEFOMP and EFOMP. There are various problems in Asia-Oceania region, and because of the diverse culture, social, education, environment background, there is a shortage of medical physicists in the AFOMP region because of the insufficient clinical training program, fewer qualified medical physicists, and the migration of the medical physicists to the European or USA. There is a lot of progress has taken place, and if you look from 2002 to 2022, the number of medical physicists has increased almost five-fold, and the number of radiotherapy machines, if you look at, there's an increment about 2.5 times. There was a slow increment during 2020 to 2022 because of the COVID. If you look at the number of medical physicists across the world, there is a variation of almost 40 times. Australia, we have almost 20 medical physicists per million population, whereas Myanmar has only 0.56 medical physicists per million population. Most of the medical physicists are working in radiotherapy, and hardly 7% medical physicists. In many countries, less than 1% medical physicists exclusively for radiotherapy are working. So there is a huge scope for expanding the functioning of the medical physicists, and many countries in Asia Pacific do not have the medical physics education program like Singapore, Nepal, Myanmar, Mongolia, where we need to increase. Similarly, we have to go a long way for the accreditation of the medical physics education program, the structured medical physics residency program as per the IAEA and IOMP recommendation, and registration of the medical physicists as the health professionals. Hardly 50% or less than that medical physicists or the countries, they have been registered as the health profession. Also, if you compare the number of medical physicists working in various regions of the IOMP, USA and Canada, almost 24 medical physicists per million population, EFOMP are about 12, but if you look at the AFOMP, it is 2.6 to 2.7 medical physicists per million population. So we have to go a long way by escalating the medical physics education program, increasing the capacity of the existing medical physics education program. And if you look at the teletherapy machines, and the number of cancer patients, there is a huge disparity among the countries from the AFOMP region. And to take care of the existing cancer patient workload by radiotherapy, we need additional 6,000 medical physicists. Leave aside into diagnosis, medical physicists required or interventional radiology or in other. Also, in AFOMP region, many countries have embarked upon the high-tech radiotherapy and also including particle therapy, like countries like China, India, Japan, and we need more and more clinically qualified, competent medical physicists in this region. However, we have to work hard. There is a progress, but this progress we need to escalate. And therefore, to make the IDMP 2022 team successful, that's a medical physics for sustainable healthcare, we need to drive more towards increment into the medical education program. But I'm sure through the solidarity, continued efforts, we will achieve our goals. Thank you for your patience, hearing, and the opportunity. Once again, I wish you very happy IDMP Day.
Great, thank you, Arun. So it is my pleasure to introduce Dr. Patricia Mora. Patricia is ALFIM's president. Patricia, can you please share your screen? And you are muted.
Okay.
Thank you.
Good morning from Costa Rica to all of you. Happy Medical Physics Day throughout the world. We're very happy to be with you this morning. So let me share my screen. Yes. Okay, now, oh, I'm so sorry. How do I make this big?
So if you click on, there is an icon on the
visualization,
right.
visualization, yes.
Oh, yes. Yeah,
This one.
Yeah.
Okay, this, as I told you, this is not my computer. I'm so sorry for that. Well, good morning again, all of you. This will be a brief summary of how Latin America is viewing this sustainable healthcare. Okay. Oh, now I got it. Thank you. Okay. Well, the medical physicist is a healthcare professional that contributes to the safety of the patient, but also to the quality of the medical service. In providing the high-quality healthcare services, the medical physics will rely on three important pillars: advanced technology in the field of healthcare, qualified personnel with adequate education and training in healthcare and technology, and intellectual system that will link the above two pillars. More and more high-tech equipment arrives in Latin America, which must be put in place to offer quality treatment and diagnosis to the patient. There are still many analog equipment in the region, but in the same way, many institutions, both public and mostly private, are incorporating very sophisticated equipment. This state-of-the-art equipment covers the three main specialties of medical physics: radiotherapy, nuclear medicine, and radiology. The medical physics must be able to collaborate throughout the entire equipment chain, from knowledge of technical specifications, standards, acceptance tests, commissioning, routine quality control checks, and even aspects of radiological protection. The medical physicist must stay abreast with technological developments, and being aware of manufacturers' own roadmaps will be necessary. Medical physics must become more involved in higher level decision processes. For example, should be aware of expansion plans, major construction projects of new guards and clinics. Latin America has increased the number of academic master's programs over the last years, but the majority of medical physicists feel that these programs provide little experience in how to deal with the real-world issues that they face when they move from the relative security of their academic physics department to the realities of modern multi-professional healthcare systems. Last year, as a joint effort between the IAA and Latin American experts, guidelines for clinical residency programs were published. An increasing number of Latin American countries now offer clinical residencies, which allow the medical physics working in the clinical environment to undergo a structured education and training programs to keep on track with the fast progress of the technological development in their field. The role of the CQMP is being increasingly understood in the region. Intellectual system is the pathway that links the two pillars. Artificial intelligence is expected to impact on healthcare processes and will contribute to a more sustainable use of resources allocated to the healthcare in the future. Artificial intelligence will change the medical physics profession in Latin America, and many opportunities will rise for the profession associated with adaptation of artificial intelligence in healthcare. Teamwork is very important, and medical physics can take an important role as they work as catalysts and motivators in the design and layout of technology roadmaps with hospital administrators, lead physicians, and medical directors. All of the above with a view of achieving sustainable health systems. The implementation of a more solid automated and remote QC with compliance programs will result in an adequate and sustainable use of material and human resources in the region. And finally, Latin American medical physicists face important challenges to achieve the sustainability of health systems, but as a group, we will seek to achieve support for the gradual growth of the development of the profession in all our countries. Strategic alliances with international organizations, professional societies, commercial companies, and other stakeholders would allow us to achieve our objectives. Well, thank you very much from Latin America to all of you. Warm greetings from Costa Rica.
Thank you, Patricia, for the information from Latin America, and happy Medical Physics Day. And now we move to second speaker, Dr. Choi Hong Young from the SEAFOMP president. It's all yours.
Thank you, Ibrahim. And happy International Day to everyone. Let me share my screen. Can you see my full screen?
Yes, Chai, we can.
Okay, thank you, John. Yeah, happy International Day of Medical Physics. I'm Chai Hong from SEAFOMP, and on behalf of SEAFOMP, I wish everyone a happy celebration. I'll take this opportunity to introduce to you the SEAFOMP. So we are located in the Southeast Asia. It's the smallest regions in the Asia, and there are currently 11 countries. And same like other regions, we have broad diversity in terms of politics, socioeconomics, culture, languages, and etc. So SEAFOMP was founded in year 2000. Very easy to remember. It's the year of millennium. And this is our current ESCOM committee. I won't go through the details here. If you need more information, you can visit our website. So to sustain the professionalism in medical physics, we first need to know the challenges that we are facing. So let me introduce or discuss with you some of our challenges here. So this data show the number of medical physics in our regions. And you can see some country like Malaysia has the highest ratio of medical physics per million populations, which is 10.7. But there are some other countries that has even less than a medical physicist per million population. So this brings up the issues of inequalities in terms of the qualified medical physics in the regions. And also in terms of gender equality, while most of the countries are facing shortage of females or women medical physicists, and interestingly, we have more females than male medical physicists in Southeast Asia. And it's mainly contributed by Malaysia, Philippines, and Thailand. So we need to have strategies how to increase or encourage more male medical physicists to join us. And in terms of different disciplines, we are quite in par with other regions. About 50% of physicists are working in radiation oncology, 30% in diagnostic radiology, 10% in nuclear medicine, 10% in other subdisciplines. But some countries, they do not have physicists in diagnostic radiology and nuclear medicine. And for the education program, the postgraduate programs, 40% of the countries still do not have a postgraduate programs. So we need to have a strategy to support each other in terms of the education and training program in the Southeast Asia. So how do we overcome these challenges? First and foremost, I think strengthening education and training play a vital role. And we are very lucky that we got very strong support from the IAEA in almost 20 years, the recent 20 years. We have this program called Regional Collaboration Projects 6038, 6077, 6087, and 6088 from the IAEA to strengthen the medical physics through education and training. And some of the countries, as you see, they do not have a medical physics program, and they might not have a senior medical physicist or chief medical physicist in the hospitals. So this is a very useful platform. It's known as AMPO, Advanced Medical Physics Learning Environment. It's an online platform supplied by the IAEA to support countries that do not have a senior or chief medical physicist as the mentors to train the mentees. And for accreditation of the medical physics academic program, most of the programs are accredited by their own national accreditation bodies. Some might have accreditation from overseas. And moving forward, I think we all need to consider the IOMP accreditation board so that we can standardize the quality of medical physics. Same as the clinical training as well. So most of the qualified medical physicists are accredited or recognized, certified by the national accreditation bodies. So the impact from this collaboration with IAEA, we have total 166, actually more than that. This number is captured in 2020. 166 residents enrolled to the IAEA residential program. And we achieved the harmonizations of the medical physics education and training through the IAEA modules. And through the AMPO, the online platform, the residents who are working at a hospital but lack of supervisor, they can share a clinical supervisor from other countries through remote supervision. And this enhances our scientific education and research collaboration within the region and also promote partnership and support from other global organizations such as IEA, IOMP, and etc. And throughout the years, from what we learned from the IEA projects, we also form our own ASEAN College of Medical Physics to support our internal training within the regions. So the vision is similar to the EFOMP schools, summer schools, or the AAPM schools. So we aim to make ACOMP the premier education and training center for medical physics in ASEAN and beyond. So these are examples of the ACOMP workshops that we have conducted since 2015. And second strategy, we also need to strengthen our professional relations so that we can promote more collaborations together. And with such, we have our conference every year. It's known as Southeast Asia Congress of Medical Physics, SEACOMP. So far, we already had our 20th SEACOMP just recently in Singapore in June this year. Sorry, this is the SAM. So through this Congress, the main advantage is for exchange of knowledge, expertise, culture, and even friendships. And during the conference, we have John Cameron Memorial Lectures. So at first, this is to memorize our great contributors, Professor John Cameron, in 2004, started in 2004. And a year later, it became a memorial lectures every year to acknowledge our great pioneers in medical physics. So these are all the speakers of the John Cameron's memorial lectures. And this year we have Professor Cynthia talking about photon counting detector city during the World Congress. And third strategy, we also need to promote science diplomacy. So we have an agreement signed in 2017. We call it as Iloilo Declaration. Iloilo is an island in Philippines. So because the agreement was signed there, so we call it as Iloilo Declarations. So during this declarations signing ceremony, so each country's sign agreement, okay, to agree on the collaborations to promote the professionalism of medical physics in the regions. And also we promote leadership and also the young leaders. So with us, we have the SEAFOMP Young Leaders Award, and we need young leaders who are energetic, dedicated, and passionate to enable the future. And we also need mentors to guide them. And this is the mentors. And there is a mentorship, medical physics leadership and mentoring program. This is not belongs to Southeast Asia, but it's a global program to guide and inspire and to nurture the younger generations. And today they have uploaded this video on YouTube for the celebration of International Day of Medical Physics. Okay, I'll skip this one. For regional collaborations, since 2021, so Professor Anchali from Thailand, she initiated a project called Regional DRL. So the members are from different SEAFOMP countries. So the purpose is to collect the national DRL from different countries and compare to each other. Right, so in time interest, so I would like to end my presentation today with this quote. Science provides the common language, culture, and foundation for nations and people to work together in decision-making on shared global interests. Okay, this is a science advisor to our Prime Minister. So basically it's to promote science diplomacy and to encourage global collaborations together. With such, thank you very much. And again, happy International Day of Medical Physics from SEAFOMP. Thank you.
Thank you, Chai. Thank you for your activities as President of SEAFOMP. And time to move from Asia to Africa. So Christoph, Dr. Christoph Trauernicht is with us. So Chris.
Thank you very much, John.
You can start.
Can you see my full screen?
Yes.
Okay, fantastic. So I also obviously want to wish everybody a fantastic 10th edition of the International Day of Medical Physics. It's a great initiative, and I'm very grateful for the IOMP for starting this in 2013. So I'm going to look a little bit at where Africa is and what FAMPO has been doing to try and help make medical physics sustainable. I'm going to keep preaching this. Africa is huge. It's roughly the same size as the US, China, India, and Europe combined. 54 countries, 1.3 billion people, 1,500 to 2,000 languages or more. We don't exactly know. And it's very often underestimated how vast Africa is. If we look at the number of medical physicists, we have seen some growth. We've probably tripled in numbers since 2010. Of course, when you have low numbers, growth rates are quite phenomenal. So of these roughly 1,041 physicists that we counted in 2020, 251 worked in imaging. And one of the big challenges we face in Africa is that only 5 countries, potentially Algeria, a 6th one, I have some conflicting information, actually require medical physicists to register with the Health Professions Council. So there's a lot of work to be done here. We also found that only 14 countries actually have a National Medical Physics Society. FAMPO does allow individual membership where a national society doesn't exist yet. And these societies are in age from South Africa is actually one of the oldest anywhere, to very recent additions like Zimbabwe. Only 10 countries offer academic training. And when you see these maps of Africa, there will be a general trend for Northern Africa being reasonably well off, Southern Africa potentially as well. And in the middle, there's very little going on. In West Africa, sort of Ghana and Nigeria are the shining beacons. A handful of countries offer clinical training. This is right now a big problem in Africa. We've had training programs that started up and went dormant again. We've had in Algeria a national cancer strategy, which was very, very fruitful. In Zimbabwe, the clinical training is incorporated into the MSc. In South Africa, it's quite formalized through the Health Professions Council. So we have the whole host of from pretty good to non-existent. Now, if we look at imaging physicists in particular, this map shows how bad it really is. So all the countries in dark red have less than 0.1 imaging physicists per million population. And Egypt is the only country that has slightly more than 1 imaging physicist per million population. And when we looked at the data carefully, we found that the number of imaging physicists is inadequate by a factor of 20 in most countries for existing infrastructure and not even for what is actually required. So what is FAMPO doing to try and work on this? So we obviously try and raise awareness that the clinically qualified medical physicists must be included in the clinical routine. And there are lots of issues in Africa, so it's really only medical physics that will look after medical physics, and we have to become better at increasing the awareness of the roles that we actually do play in the clinical routine in Africa. One of the fairly low-hanging fruit is the formation of national medical physics societies. FAMPO has been encouraging this. It just turns out that if you have a national society, you have much more leverage with the Health Professions Council, for example, or the regulator to get things done. Regulatory infrastructure in many countries in South Africa, it's it's rudimentary to non-existent. And so a good regulatory infrastructure would certainly help improve the situation. Professional certification for medical physicists. So this is something that, like I mentioned, only happens in a handful of countries. FAMPO has been working on accrediting some of the training programs and has even started registering some physicists in the absence where national registration doesn't happen. And this has had a very positive echo. And finally, how can we make medical physics sustainable? We have to work on the number of academic and clinical training programs. They have to be expanded. We have to figure out how graduates from these programs or those training abroad can be employed in their home countries and encouraged to set up training programs in their own countries. So with that, I want to thank you. My 5 minutes are over. I just have to mention that starting from Thursday, we have our first regional conference of medical physics happening in Morocco, and we're very excited that this is actually happening. That's it from me. Thank you very much.
Thank you, Chris, for this informative information about Africa. Well, you have a lot of things to do in Africa, and we hope that other regional organizations will be of help to you if you would like to need them. Now we move to the sixth speaker, Meshari AlNuaimi from Kuwait, presenting MEFOMP president. Meshari, is all yours. You can unmute yourself and share your screen.
Okay, thank you for the introduction, Ibrahim. Just give me a moment to share my screen.
Yeah.
Okay, can you see my screen?
Yes.
Yes.
Okay. Hello, everyone. I'm Meshari AlNuaimi, president of MEFOMP, and I will talk about current status and future perspectives for Middle East Federation of Medical Physics, which was established in 2009 for the purpose of supporting the development of medical physics in the region, with 12 participating countries: Bahrain, Iraq, Jordan, Kuwait, Lebanon, Oman, Palestine, Qatar, Saudi Arabia, Syria, UAE, and Yemen. We want to advance medical physics in the region, and this should be achieved by these four fundamental pillars: by building confidence and achieving excellence, and support professional development, and also enforce partnership. So I will give you some information about the current status of medical physics in the Middle East region. A recently published article by Dr. Hassan Kharita, the Vice President of MEFOMP, described the current status of medical physicists in the Middle East, and the information was obtained by a questionnaire submitted to different countries, and information gathered from this survey. And this article also focused on the number of equipment available in each country, number of medical physicists, and the availability of education and training programs. So this is to show you the distribution of medical physicists in the Middle East. As you can see, the largest number of medical physicists are in Saudi Arabia, more than 55%, and followed by Jordan and Iraq. The number of medical physicists available per million of population is 8 medical physicists per million, which is acceptable, but lower than the number of physicists in the developed countries. So we are aiming to encourage increasing the number of medical physicists in the Middle East countries. The number of female and male physicists are almost the same, with slightly higher number of females, about 16%. And this table shows the profile of medical physics societies and Association Middle East. The Lebanese Association of Medical Physicists was the first to establish in 2005. And the total number of medical physicists in the region is about 1,200 medical physicists. And to give you some information about the equipment available, the number of radiation therapy or teletherapy units per million population is 1, which is relatively low. And the number of CT units per million of population is 13.4, which is also low. The number of nuclear medicine equipment per million population is 2.8. And you can see the variation in the number of equipment, which is expected due to the big variation between countries, mainly due to the ongoing instability and conflicts in some of Middle East countries, which resulted in different tracks of development for medical physics in each country. That's why we have an ongoing commitment to support the development of medical physics profession in these countries and sustain the support of medical physicists to healthcare providers. Here you can see the number of universities that provide medical physics educational program, offering five countries actually provide the BSc program, as you can see here, and also the same countries also provide the master degree in medical physics. And some of the countries are, as I mentioned, are suffering from conflict and instability. So still, we need higher number of educational program for medical physics to enhance the number of medical physicists in the region. Because there are no national or regional certification board as an interim solution, MEFOMP and some national societies in the region, in collaboration with the IMPCB, started to carry out certification exams in the region to support the practice of medical physics through a certification program in accordance with the IOMP guidelines. During the last 2 or 3 years, we have organized different examination for part 1, 2, and 3 in different countries in the region. So what are the actions to empower the medical physics profession? Mainly, we are aiming to support professional development by providing training, education, and resources, learning resources for medical physics in the region, like organizing workshops, conferences, and also e-learning platforms. So we have organized a virtual conference last year, which was very successful with more than 2,000 participants online. And next year we'll organize a conference which will be between 19th and 22nd of May 2023 in Oman. And the registration is free, no registration fee. So I welcome all of you to join us in this conference. And the submission for abstract is open now. You can check the site mefomp-conference.com. Also, we are working on establishing an online academy for medical physicists, which is an online platform to provide a learning environment for medical physicists, scientists, and students in the region, and also globally. This platform will offer exclusive live streaming for some events in the region, like workshops or training courses, and also an extended and constantly growing on-demand library and best topics packages related to medical physics. So we are working on this. It will be available soon. Also, another important aim for MEFOMP is to ensure effective communication with the medical physics community in the region. And this is by exchanging knowledge, ideas, and information by using the social media and YouTube and podcast to make sure that we deliver the right information by different social media accounts. Also to support medical physicists and to recognize and acknowledge scientific significant contribution to the medical physics field. MEFOMP have also awarded 2 awards. Actually, 1 award was given this year only and established, this year, which is the Outreach and Engagement Award. And also we have the Young Scientist Award to recognize medical physicists with outstanding performance. Also, partnership. We are also promoting cooperation and partnership among medical physics society in the region and globally by supporting and endorsing events like conferences or workshops. For the future of medical physics in the region, I would like to say a few words that to advance medical physics profession in the region, I would like to highlight some areas of potential improvement in the future. For the short term, we want to promote, as I mentioned, the highest standard of education, training, and research in the region. And for the long term, also, we want to make sure that there is an effective communication to enhance visibility and recognition of the profession, because again, we have some challenges in the region of lack of recognition of medical physicists in some countries. So we want to make sure that the field is recognized and medical physicists are visible to the healthcare providers and to the community. And ultimately, we want to ensure sustainability in providing effective medical physics support to the healthcare providers. So sustainability by preserving and enhancing the medical physics services, which we believe is a key priority to move forward. So we are committed to find sustainable ways to provide effective and efficient medical physics support to the healthcare provider and for the community to ensure patient care is safe and of high quality. Thank you. Thank you for your attention.
Thank you, Dr. AlNuaimi. Thanks to online platforms, we can move from one continent to another in seconds. So it's time now to go to the United States. And it is my pleasure to introduce AAPM's president, Dr. J. Daniel Bourland. Dan?
Greetings to all. It's a pleasure to be here, and I'll share my screen. Okay, let's see. Can you see the?
Yes.
Thank you so much. It's a pleasure to be here. And on this particular day, so we celebrate. There are a number of challenges. We've heard about many of them. And these are also opportunities for sustainable healthcare and how medical physics can contribute to this. The AAPM has about 10,000 members. These include international. Our motto, so to speak, is improving health through medical physics. That's our vision. There are a number of issues associated, and Partnerships and collaborations, as we're discussing today, are very important for sustainable healthcare and to be relevant. I wanted to review just a few of these by letter. Communication. For physicists, we often do very well at, for instance, mathematics. We're finding this is also important, to say hello and to communicate. This is what we're doing today. We communicate about our education, our science, our practice with colleagues, with patients sometimes as well. Very important to discuss also with healthcare teams and administrators, those who are not medical physics oriented, and the public. So each time we speak or write, we convey for our field, our safety, the effectiveness of what we're doing, our innovation and our purpose. So communication, very important. For education, we've heard about the number of education programs that are available. Here within AAPM, our membership has a number of graduate programs and residencies. We've adopted a medical model relative to our postgraduate training. These are credentialed by CAMPEP and the ABR and potentially by others as well. I just wanted to point out one item about teaching, education. There's a quote from the 1870s about the ideal college. The ideal college is Mark Hopkins, that is the teacher, on one end of a log, the student on the other. So this is about mentoring. We teach each student about the life of a medical physicist, whether it's science, education, practice, whatever it is we're doing. We are about science and technology applied to people. So we are about people. That's why we're talking today. There's a book from the 1970s in the US called The Patient as Person, a good reminder that the patients we treat are individuals. They are people. I wrote a little poem, but it's about today. Why today? Because it's Madame Marie Curie's birthday. She had quite a feat, 2 Nobel Prizes. She transformed the world, and that's what we're talking about today. How can we as medical physicists transform the world? Dr. Yeong mentioned about science diplomacy. This is about science and policy. That is a difficult mix sometime. Carrie Boras spoke about this at the World Congress in Singapore this year and thought, well, what is this about? Well, it's about, she thought of a poem, How Do I Love Thee? Let Me Count the Ways. And the reminder here is that we communicate and practice best what we really care about. So when we really care about medical physics, that will come through in all of our communications, how we teach, how we talk with those who are non-physicists like policymakers. Within the AAPM, we have integrated our various international initiatives into a new council formed about 2 years ago now, led by Jatinder Palta, called the AAPM International Council. The vision is for sustainable, measurable, meaningful impact for medical physics throughout the globe, and with working on strategies to help with this. A reminder is that on aapm.org, all of AAPM's consensus documents are available for those who would like to access them. Here are the activities of the International Council. This is what they are now working on to assess needs relative to medical physics outside of North America, to work on effective communications and harmonize. This is why we're meeting today, to support education and training programs elsewhere outside of North America, to provide even training that relates not just for medical physics, but also for physicians, radiation oncologists, other allied health professionals, all who make up the team. We don't operate in a vacuum, we work with others. The International Council is working on an electronic platform to help with coordinating these types of things, and then also to facilitate global medical physics research activities. And we think about research, sometimes it's the hardest thing to do. However, yet very important for us to understand the problems that are relevant wherever that may be occurring, and then to provide solutions. For science and innovation, we've already heard about AI. We've heard some about technologies. What would be a benefit? simpler, smaller packages, those that are mobile, those that would operate with less infrastructure, and of course, very importantly, people, to get educators and practitioners in the right location. For AI, I'll mention that we have one initiative within AAPM to provide like AI 101, a basic course in AI for all medical physicists. The AAPM annual meeting had essentially a theme of celebrating medical physics, transforming human health. This is a bold statement, to transform human health, but medical physicists are able to do this. This is the logo. This is about what we're about. We want to impact through medical physics. We're critical thinkers. We solve both big and small problems, and I often think the small problems are sometimes the most significant and allow the big problems to be solved. And we're communicators. So I'll summarize with this, that we are about transforming human health. To impact our world, transform our world with medical physics, communication in this is going to be very important, and to not underestimate significance of one's contribution. I do think for medical physicists, with a global perspective, we need to think about public health, to be public health scientists, to help with problem solving. They may not be expressly the typical medical physics we think about, but we might be asked to help with that, and it would be good to say yes. And we're working also towards cooperative agreements that are across boundaries. So I'll end with transform human health through our medical physics. We'll cooperate, collaborate, we're better together. So thank you, and let's keep working on this together.
Oh, thank you very much, Dan, for this world of medical physics world map. And we will reach to our final presentation by the COMP Canada President, Boyd McCurdy. And I will leave the floor for you.
Good morning. My name is Boyd McCurdy. I'm the president of COMP, and I'm just trying to share my screen here. Up there we go. So I've decided to do something a little different. I've got basically just going to point you to our website here, and hopefully you can all see that. So I'm so pleased to be with you this morning and join you to help celebrate the International Day of Medical Physics 2022, and participating in this event on behalf of COMP, the Canadian Organization of Medical Physicists. As in many regions in the world, the ongoing global pandemic has highlighted the fragility of Canada's healthcare system as a whole. The IDMP 2022 theme of medical physics for sustainable healthcare is therefore particularly applicable in this context. As medical physicists, we are uniquely positioned to understand the technologies that are key to sustainability in many areas of medicine, but also understand the value of optimized clinical workflows and the importance of education and training, which are needed to link this understanding together. Today in Canada, the medical physics profession is a vibrant group of approximately 600 excellent scientists who are passionate about providing high quality support in healthcare. As medical physicists, we are aware of efficiency and sustainability in the work we do, and are constantly looking to optimize the value added to the healthcare system for our invested effort. Adapting is a good descriptor of our current status as a profession. Over the last few years of the pandemic, many Canadian radiotherapy programs, hospitals, and imaging departments have made significant changes in practice. For example, embracing few fraction or even single fraction radiotherapy regimens, or incorporating flexible remote working configurations while still maintaining high productivity. Now, as we slowly emerge from the pandemic, we are adapting again and maintaining some aspects of our pandemic learnings while bringing some previous approaches back into practice. COMP, our professional organization in Canada, has a long history of strong support for education and training of its members, as well as networking and communication support, which are key elements for sustainable healthcare. One of the main objectives in our strategic plan includes knowledge acquisition and dissemination, where we are trying to ensure that all medical physicists in Canada can create and have access to relevant scientific material. We are attempting to achieve this objective through initiatives such as online document management system, access to and timely development of professional technical guidelines, facilitating more continuing education opportunities, and seed financial support for scientific training and mentorship opportunities. A second related main strategic objective of ours is to improve membership networking and engagement in a manner that is inclusive and welcoming to all stakeholders in the medical physics community. We are attempting to achieve this through several initiatives, including providing more networking and engagement opportunities, both in person and virtual. Improve our social media usage to attract and engage members and potential members, and support communication amongst communities of practice. For example, medical physics training program directors. An important recent activity in networking and engagement is COMP's first climate survey on equity, diversity, and inclusion performed in 2021. Survey results have been analyzed and a manuscript has been submitted to a peer-reviewed journal. The study provided insights into the diversity and experiences of medical physicists in Canada. While the majority of respondents had positive perceptions about their professional environment, there were equity-lacking groups identified, such as women, underrepresented minorities, Indigenous peoples, and people with visible and invisible disabilities. As a professional organization, improving our networking and engagement across all aspects of society will help create a more inclusive environment which facilitates sustainable healthcare. Our future plans for COMP continue to focus on further promotion of scientific training and mentorship, and further improvement communications and knowledge sharing amongst members nationally and internationally. Examples of specific new initiatives being pursued include adding a virtual library of scientific content gleaned from conferences and workshops, fostering partnerships between academic and clinical medical physicists to increase research interest and opportunities, developing a module on our website to facilitate communities of practice engagement across the country in order to provide online forums to support exchanging of ideas on research, clinical practice, quality and safety, ethics, and professionalism, as well as software development. In conclusion, the theme of this year's International Day of Medical Physics is highly relatable and very important in Canada. The Canadian Organization of Medical Physicists is committed to empowering our profession to support the transformation of healthcare towards sustainability. On behalf of COMP, I wish all medical physicists in the world a happy IDMP 2022. Thank you.
Thank you, Dr. McCurdy. Ibrahim, would you like to announce the IDMP awardees?
Yes, sure. I will just ask from Boy to unshare, stop sharing his screen.
I'm trying to do that. There we go. That should
Okay,
work.
we have also uploaded a relevant announcement on our website, but it is good if you show your slides.
And I think this is the International Day of Medical Physics 2022 awardees. We would like to congratulate 3 awardees for this year. Angelique from SEAFOMP, Rabi Hamoud from MEFOMP area, Jeffrey Ebert from AAPM. Congratulations to all 3 of you, and we are very grateful for your contributions to the medical physics in the world. Thank you very much, and congratulations.
Thank you, Ibrahim. Time flies. It's 14 minutes past 5 here in Vancouver in the morning. So it's still early in the morning. We are all busy today trying to organize events, reply to messages, and of course provide our usual clinical and other services. We are behind schedule, and I'm afraid we have to skip discussion this time. So we'll close this webinar. I'd like to thank all speakers for their wonderful presentations and our international audience, our colleagues, for their participation. So happy IDMP, everyone. Take care. Bye-bye.